Hello, science fans! Today we're diving into the electrifying world of giant power generators. These are the machines that make the electricity for our homes, schools, and, even our video games. Inside every generator is a part called a rotor. Think of it as the heart of the generator, spinning around super fast. This rotor is covered in special wires called windings. These windings are like the generator's veins, carrying a type of electricity called direct current, or DC. This DC current creates a powerful magnetic field, which is the key to making all that electricity we use every single day. It's a marvelous piece of engineering, working tirelessly behind the scenes. Now, all this electrical stuff needs to be kept safe and sound. The rotor windings are carefully wrapped in something called insulation. Insulation is like the plastic coating on a phone charger cable. Its job is to keep the electricity inside the wires and stop it from going where it shouldn't. It's a barrier, a protector, a guardian of the electrical flow. This insulation ensures that the electricity only travels along the path we've designed for it. Without it, things could get very messy, electrically speaking. It is absolutely critical for the safe and efficient operation of the generator, preventing unwanted electrical detours that could cause major problems. A rotor earth fault happens when this insulation gets damaged. Imagine a tiny crack or a weak spot in that protective coating. When that happens, the electricity can leak out of the rotor winding. It finds a new path and connects to the metal body of the rotor, which is connected to the ground, or earth. So rotor earth fault is just a sciencey way of saying the rotor's electricity is taking an unplanned shortcut to the ground. This creates an electrical connection that was never supposed to exist, breaking the carefully designed circuit and setting the stage for potential trouble down the line. So, what does this mean? Well, at first, a single earth fault might not seem like a big deal. The generator might even keep running as if nothing is wrong. It's a sneaky problem. The current has found one little escape route, but the main circuit is still mostly intact. However, this single fault is like a warning sign. It's a hidden danger lurking inside the machine, waiting for a second fault to occur. Think of it as a small leak in a boat. One leak might be manageable, but it's a clear signal that the boat's integrity is compromised, and a bigger problem could be on the horizon if it's not addressed. You might be wondering, how does that super strong insulation even get damaged? Well, it's a tough job being inside a generator. The rotor is constantly spinning at incredible speeds, thousands of times every minute. This creates immense mechanical stress and vibrations. Over many years of spinning and shaking, the insulation material can start to get tired and weak. Little cracks can form, just from the sheer physical forces at play. It's like bending a paperclip back and forth. Eventually, it weakens and breaks. The constant push and pull on the components slowly wears them down. Another culprit is heat. Generators get very hot when they're working hard to make electricity. This heat can cause the insulation material to age and become brittle over time. Think about an old rubber band left out in the sun. It gets dry and snaps easily. The same thing can happen to the insulation inside the generator. Overheating, whether from heavy use or problems with the cooling system, accelerates this aging process. This thermal stress is a major factor that contributes to the breakdown of the very materials designed to keep the electrical currents safely contained within their pathways. Contamination is another big one. Tiny particles of moisture, oil, or even conductive dust can find their way inside the generator. These contaminants can settle on the rotor windings. Over time, they can eat away at the insulation or create a conductive path that helps electricity leak out. It's like spilling a sugary drink on your keyboard. It gets sticky, attracts dirt, and can eventually cause the keys to stop working correctly. Keeping the inside of a generator clean is incredibly important for its long-term health and preventing these kinds of sneaky electrical failures from developing. Finally, sometimes faults just happen because of how the generator was made, or if it gets a sudden, powerful jolt. A tiny imperfection during the manufacturing process might only show up after years of operation. Or, a big electrical surge on the power grid, like from a lightning strike nearby, can put a massive strain on the insulation, causing it to fail suddenly. These events, though less common than gradual wear and tear, can cause significant damage in an instant. It's a reminder that these powerful machines are complex and need constant care and attention to operate safely. So, we have one little earth fault. The generator is still running, What's the big deal? Well, the real trouble starts when a second earth fault happens somewhere else on the rotor winding. Now, instead of just one leak, we have two. This is very, very bad news for the generator. With two fault points, the electricity now has a major shortcut. It can flow directly between these 2 points through the rotor's metal body, completely bypassing a section of the winding. This is what we call a short circuit, and it's a big problem. This short circuit causes a huge, uncontrolled flow of current through the rotor's body. This can create intense heat at the fault locations, enough to melt the metal of the rotor itself. Imagine the kind of heat needed to weld steel. That's the kind of energy we're talking about. This can cause severe, sometimes irreparable damage to the rotor forging. In a real-life example from a power plant, a double earth fault led to such intense arcing that it burned a large groove into the main rotor shaft, requiring a multi-million-dollar repair and months of downtime for the power station. This electrical mayhem also messes up the magnetic field we talked about earlier. The magnetic field, which needs to be perfectly balanced, suddenly becomes lopsided and distorted. An unbalanced magnetic field will cause the rotor to vibrate violently as it spins. These are not small vibrations. They are powerful enough to shake the entire multi-ton generator. This can damage bearings, seals, and other critical components of both the generator and the turbine that spins it. The shaking can be so severe that it forces an immediate and emergency shutdown of the entire unit to prevent catastrophic failure. Worst of all, these powerful vibrations and the damage from the short circuit can lead to a complete breakdown of the generator. We're talking about a catastrophic failure. Parts could break apart at high speed, causing a major safety hazard for anyone working at the power plant. And of course, it means the generator stops making electricity. This can lead to power outages for thousands of people and cost millions of dollars in repairs and lost revenue. It's a chain reaction that starts with one tiny, undetected fault and can end in a spectacular and expensive disaster. That's why finding that first fault is so important. Because a double fault is so dangerous, engineers have come up with some clever ways to find that first single earth fault before it can cause trouble. It's all about early detection. The most common method is to use a special monitoring system. These systems constantly check the rotor's electrical circuit for any signs of a leak to earth. They work by injecting a small, separate electrical signal, either AC or DC, into the rotor circuit. They then measure if any of that signal is escaping to the ground. If it is, an alarm sounds to let the power plant operators know there's a problem. Once a fault is detected, the next step is to find exactly where it is on the winding. This is like being a detective. One cool method involves using a special high-frequency signal tracer. With the generator stopped, engineers connect a signal generator to the rotor winding. They then use a handheld probe to sniff along the rotor body, listening for the signal. The signal will be strongest right at the location of the fault, where the electricity is leaking out. This allows them to pinpoint the damaged section of insulation without having to take the entire rotor apart, saving a huge amount of time and effort. Fixing the fault usually means the generator has to be taken out of service and the rotor removed. It's a huge job, like open-heart surgery for a generator. Once the rotor is out, technicians can carefully inspect the pinpointed area. The repair might involve cleaning the area and applying a special epoxy resin to patch the insulation. For more serious damage, they might have to rewind a whole section of the rotor, which means replacing the copper wires and the insulation entirely. It's a delicate and precise job that ensures the rotor is as good as new. Ultimately, preventing rotor earth faults is all about careful maintenance and continuous monitoring. Regular inspections, keeping the generator clean and dry, and operating it within its temperature limits all help the insulation last longer. And by using modern detection systems, we can catch that first sneaky fault. This allows for a planned repair before a second fault can occur and cause a disaster. It's a fantastic example of how science and engineering work together to keep our power grid safe, reliable, and lighting up our world. Consider it.